this video, we will discuss friction, and we will discuss how friction applies to Newton's second law. So, just a quick review on the force of friction. What we will show is big F, little f. It's as an object moves across the surface, there's a force that pushes back against it. Now, it's not third law, it's not equal and opposite, but it does oppose the motion of an object. So, for example, a book sliding to the right, if you're pushing it to the right, you're applying a force that direction, but then there's going to be some friction going backwards. And as long as you're accelerating, your applied force will be greater than that of friction. Usually the surfaces are pressed together, and the molecules are rubbing together, and that's what's causing this force to occur. Usually friction depends on the nature of the surfaces, so depending on what rubbing against each other, they could have more or less friction, which would affect the acceleration of our object. Now we can quantify that by saying force of friction is equal to a constant times normal force. Normal force, as you recall, is just the perpendicular force to the surface. This coefficient of friction is based on the sum of the two surfaces that are rubbing together, and this number, and we call this thing mu because it's the Greek letter mu. It could be anywhere between 0 and 1, and closer it is to 1, the more friction that you get, the rougher the surface is, if you will. And so that's how we figure friction, mu times normal force. Now, the types of friction, you got sliding and static. Sliding friction are when surfaces are sliding across each other or rubbing. Static friction is very similar to inertia. Static friction is the friction that occurs before an object starts to move. So an object that's hard to move has a lot of static friction because it has a lot of inertia. So an example of a problem would be this, and the free body diagram's drawn for you. I'll do one where I draw it so you can see. But here's what we know. We're applying a force of 20 newtons, and we got a frictional force of 10. And we know the weight is 100 newtons. And we need to find normal force, coefficient of friction, mass, acceleration, and net force. Really, we're just going to try to find everything. Usually it's just one thing we need to find, but this time we're going to try to find a bunch. So first thing I want to do is, if I know the force of gravity, I know that is equal to mass times g. On Earth, g is 9.8, which means I can solve for mass. So force of gravity is 100, g is 9.8, solve for m, divide both sides by 9.8, and I get a mass of 10.2 kilograms. Now, because my surface is horizontal, I can make the assumption that normal force and gravity are the same. So my normal force is a very easy 100 newtons. Now, what this leads me to is that now I know my normal force being 100 newtons. I can then find my mu because my frictional force is 10. So I know my force of friction and I know my normal force, which means I can solve for mu. So if I divide 100 by both sides, I get a mu of 0.1. Again, no units with mu. It's a quantity. It's a constant that shows us about the surfaces. Once I know mu is 0.1, then I go on and I'm trying to find net force. Now, since normal force and gravity are the same, the net force is going to be in the x, or on the horizontal, and I got applied force greater than frictional force, which means applied force is positive and frictional force is negative. So I just take 20 minus 10, and I get a net force of 10. So my net force is 10 newtons. Lastly, define my acceleration. Net force is equal to mass times acceleration, Newton's second law. My net force is 10. My mass from the first part of the problem is 10.2. I solve for A, so I divide both sides by 10.2. And I get an acceleration of 0.98 meters per second squared. Now, a problem that would be similar to something you'd see on mastering would look like this. We have an object that we're applying a force of 4.25 newtons to. And we're moving it to the right, and it's accelerating. So there's going to be friction, but the frictional force will be less than our applied force. We know the coefficient of friction is 0.410. Other forces we know is gravity and normal force. Now, gravity and normal force, since we're on a horizontal surface, are going to be equal. So once I find gravity, I'll find normal force. First step, if I can find the force of gravity or use the force of gravity to find information, I will. And I have enough information to do this. Force of gravity is mass times g. I know the mass. and I know g is 9.8. So I multiply those two numbers, and I get the force of gravity to be 7.5 newtons. Normal force is also 7.5 newtons. So I know my normal force and my gravitational force. Now from there, I want to find my force of friction. Now, if you recall, we have a normal force. I'm going to redraw this of 7.5 newtons. So if my normal force is 7.5 and my coefficient of friction is given to me as 0.410, when I multiply those numbers, I know my force of friction. So I know my force of friction is 3.1 newtons. Now I take my applied force of 4.25 and subtract my frictional force from it, and that gives me a net force of 1.15 newtons. Then I know my net force, and I know my mass. I can solve for acceleration. So I take my net force of 1.15, make it equal to my mass of 0.765 kilograms, and I multiply it by a. I divide both sides by 0.765, and I get an acceleration of 1.5 meters per second squared. Again, I just went through this process, 5-6 steps, but they're their equations, all multiplying and dividing. Not a lot of fancy math like you saw with kinematics, sometimes. So here we got another picture, and we got some different knowns. We know the coefficient of friction, we know the mass, and our acceleration is 0. And that's important to talk about. If we talk about constant velocity, there are some things we can take for granted, and we'll talk about that. So again, first step, always, can I find gravitational force? And I can. The force of gravity is mass times g. My mass is 10 kilograms. G is 9.8. Multiply them together. Force of gravity, 98 newtons. We're on a flat surface, so gravity and normal force are both going to be 98 newtons. I have 98 and 98. Now I can start working through some other things. Force of friction is mu times normal force. So I found my normal force to be 98 newtons. My mu is 0.2. So if I take 98 times 2, I get a force of friction of 19.6 newtons. Going to the left. Now, my net force. My net force is mass times acceleration. If I'm going at a constant velocity, I have no acceleration, which means my net force is 0. So my net force is 0 newtons. Which means I can find my applied force, because net force is just going to be applied minus friction. I found my frictional force to be 19.6. My net force is 0. So force applied minus 19.6 equals 0 means my force applied is also 19.6. So this is mathematical proof, but here's something you can take a shortcut for. If all forces are balanced, if you know one of your forces is either frictional or applied, the other is going to be equal at 19.6. So you don't have to do this last step. It's pretty simple that if you see that constant acceleration of 0, that you can make that assumption. Okay, another one. We have somebody sledding, and leave me alone. Funny name. But they're sledding, and it is exerting a rightward force of 9.13 newtons on his sled. And his sled has a mass of 4.68 kilograms, and the acceleration is 0.815. What is the coefficient of friction? So I'm trying to find mu. What is my mu? Again, first step, force of gravity is acting on this thing, as is normal force. Since we're on a horizontal surface, they will be equal. Force of gravity is mass times g, 4.68 times 9.8, which gets me a force of gravity of 45.9 newtons. Which means my normal force also is 45.9 newtons. Now, my net force is going to be mass times acceleration. I know the mass and I know the acceleration, so I can do that and I can find my net force. So my net force is 3.8. So let's think about this. I have an applied force of 9.13. I have a frictional force that I don't know, but I do know my net force. So my net force is going to equal applied minus friction, which means when I bring this over, the 9.13 over, and then divide by -1, I get a force of friction equal to 5.33 newtons. once I know the force of friction, I know the normal force from before is 45.9, I can solve for mu. So I set the equation up like so, divide both sides by 45.9, and I get a coefficient of friction of 0.116. So then I know what my surfaces are doing. Hopefully these examples were beneficial. Don't be afraid to go back and watch them again. This will help you on the mastering assignments for sure.